Hey everyone, this is Mrs. Hilt, and in this video I'm going to walk through 4 different heat calculation problems. In each problem, we're going to solve for a different variable, and those are outlined right here. Even though we've already had practice solving for Q, we are still going to have one of those because in this example, we're going to end up solving for calories instead of joules as our final unit. All right, please follow along with the slides I posted on Classroom. They have the same questions, and you'll get the most out of the video if you are practicing the calculations right along with me. All right, so solving for calories. If you're ever asked to solve for calories, what you really need to solve for first is joules. Okay, so we are solving for Q the same way that we have been. And we will set it up just like we have been. And you guys probably noticed by now that I use a lot of parentheses when I am writing out my calculations. And the reason why is just to keep all of my work organized. And that's actually supposed to be 82.2 degrees Celsius. All right, now that we have everything written out, you just plug that into a calculator. What you'll get is negative 15,461.82 joules. All right, now, but we are not done because we still have to convert joules into calories. And this conversion will be just like if you were asked to convert inches into feet. Okay, so performing a little dimensional analysis like we know how to do. And also notice that I didn't round my final answer yet to the correct sig figs. And whenever you guys are performing calculations where you need to continue your calculation, like we're doing right now by converting joules into calories, wait to round your final answer until you have finished all of your calculations. All right, so use the conversion factor that I had written to the side, that there is 4.184 joules per 1 calorie. So I'll take the number of joules and divide it by that to get negative 3,699 calories. All right, so negative calories means that this was released, which does make sense. It adds up to our problem. So when you write your final answer, you can state this as negative or just knowing that the calories were released. That's really the same thing as having the negative sign there. If we round this to the correct sig figs, it would be negative 3.70 times 10 to the third calories. All right, let's move on. Okay, so solving for final temperature. And how we go about this problem is not even very similar, almost the exact same as how you would solve for initial temperature. Once we get to the very end of the calculation is when you'll see the difference between solving for initial and final. All right, but these type of problems always mess students up. I see it every single year, and the reason why is because students don't know what to solve for first. So you can't start off solving for the final temperature. What you have to start off solving for is the change in temperature. Then, once you have the change in temperature, you can find the final temperature or initial, depending on what you're asked for, just by performing addition and subtraction. All right, so we will first, I'm going to rearrange the equation so that T is all by itself, or delta T is all by itself. Q equals MC delta T. And you can do this with the numbers plugged in or not. I just think it's easier to rearrange when there aren't numbers there. All right, to cancel out the multiplication, we divide each side by mass and specific heat so that delta T is equal to Q divided by MC. All right, I'm gonna switch sides actually. Delta T is equal to Q amount of joules divided by the mass. Okay, now that we're at this point, we plug this into a calculator and we will get a change of temperature of 42.8 degrees Celsius. All right, now that we have the change, we can plug that into our delta T equation. Oops. And solve for TF. So our final temperature is, 64.8 degrees Celsius. And that conveniently has the correct number of sig figs. Cool. All right, and again, if you were ever asked to solve for the initial temperature, this is the only part, I'm going to even highlight that. This is the only part that would change if you are solving for final temperature. Initial temperature. All right, on to the next one. New problem, new color. So this one we are solving for specific heat. And what I'm going to do is, again, rearrange my equation so that C is all by itself. And just like the last problem, you need to isolate what we want to solve for. And we have to cancel out multiplication with division. And what you do to one side, you have to do to both. So solving for C, Q divided by M delta T. And we can always double check that by thinking about the units. So that we know that Q is joules, mass is grams, and degree Celsius is temperature. Those are the units that we need for C. Therefore, if we plug everything in just like that, we will get specific heat. So the specific heat, and this is of platinum, will be equal to I love problems that have the change in temperature already calculated. I know it's just a little subtraction problem, but it feels nice. It's like a little bonus that they gave you. All right, so plug this into a calculator and you will get a specific heat of platinum to equal 0.1337 joules per gram degree Celsius. Okay, but that is not written to the correct number of significant figures. If we round that to sig figs, our answer is 0.134 joules per gram degree Celsius. Okay, we have one more, and in this one we are solving for mass. Okay, so I am again going to rearrange my equation. We have and again, cancel out multiplication with division. What you do to one side, you have to do to both. The mass is Q C delta T. All right, and let's plug that in. All right, and let's see how the units cancel out. So joules cancels out. We have one in the numerator, one in the denominator. Celsius, since they are being this one, my pointer, this Celsius is actually in the denominator of this one. So that is how that and that one cancel out. And because the grams is in a double denominator, remember again, these two are in the denominator of this value, it ends up being in the numerator, and that's how we end with grams as our final answer. All right, so mass is equal to, but that is not written with the correct sig figs. The correct number of significant figures is 137 grams. Box that in. All right, thank you for watching, and let me know if you guys have any questions.